Welcome to class today, students. We are going to be learning about the water cycle today. Today is just going to be introduction, and I thought this was a really great picture I found online showing the different steps of the water cycle. You'll see that there's surface runoff, going to evaporation, going to condensation, going to precipitation, which is rain, which we all know about here. And then we have these other parts going on down below the ground. And we're going to go through a bunch of these as we go through the water cycle. Today's just the introduction, so let's go ahead and move on. I'm going to scroll down the page here. And this is your TCI book. We're going to read the introduction together, starting up here with look. So we have, look at this photo of a whitewater kayaker running a waterfall, as it's called in the sport. It's a risky maneuver even for experienced paddlers, not only because of the drop, but because moving water has tremendous force. But did you ever wonder where the churning water came from? How did it get to the top of the mountain? And what causes it to rush downstream? Where does the water go, and what will happen to it there? You've learned that energy causes rock to cycle in the geosphere. The same is true of water in the hydrosphere. However, most of the energy that moves water does not come from Earth's interior. It comes from the sun. The sun's energy causes water to move and to change state. If it weren't for the vast amount of energy from the sun, this kayaker wouldn't have such an exhilarating ride down this waterfall. In this lesson, you will learn how energy from the sun and Earth's gravity work together to cause water to cycle between the biosphere, hydrosphere, atmosphere, and geosphere. As you will see, water constantly changes between a liquid, a solid, and a gas as it moves from one place to another. Finally, you will learn how a university student designed a way to turn fog into drinking water for people living in a desert. Ooh, that sounds cool. And again, here's our kayaker on the waterfall going down. These are really short little kayaks that help them to be able to tolerate going down these big falls like this. So let's move on to our first section. Section 1. Again, this is in TCI. If you'd rather read, you can look this up in TCI under the water cycle, Section 1. So this is called heating and the water cycle. Suppose you can follow a water molecule as it cycles through Earth's systems. The journey begins with the water molecule on the surface of a lake at night. Molecules are too small to see with the naked eye, of course. But you have a superhero's microscopic vision, so you can follow your water molecule along with others. At sunrise, all the water molecules start to move even faster. Before you know it, your water molecule is no longer in the lake. It's soaring free in the atmosphere. How does the water move from the Earth's surface to the atmosphere? Now we're at this paragraph. The water cycle is the global movement of water powered by energy from the sun and Earth's gravity. Water continuously cycles between Earth's surface, including land, oceans, and organisms, and the atmosphere. The movement of water in the water cycle has no starting point, but the journey in this lesson starts with water moving from a body of water on land into the atmosphere. Now we're down on evaporation. Water moves from the Earth's surface into the atmosphere through evaporation, which is the change in state from liquid to a gas. Most evaporation is from the oceans, lakes, rivers, but it can take place anywhere there is water and energy from the sun. I'm going to scroll down just a little so we can see this better. And we're starting here with 2. To understand evaporation, it is useful to use a model. Recall that models can describe processes that you cannot see directly. Figure 1A, and we'll see that in just a moment, is a model that shows the process of evaporation. Energy from the sun causes liquid water molecules to move faster and collide with each other more vigorously. Some of the molecules on the surface move so fast that they break away and enter the atmosphere. When this happens, liquid water evaporates and changes into water vapor. So here's our figure 1a that they talked about above, and this figure is called how water evaporates. Now if we look at this, we see a bunch of different things happening. They tell us that this diagram, and I'm reading this right here, this diagram models how water molecules evaporate. You cannot see this directly, but energy from the sun causes water molecules to move faster and faster and break away from the surface of the liquid water. When this happens, water changes state and becomes vapor. So in our illustration, we see sunlight right here, and sunlight is energy. So it's energy that's striking the surface of this liquid water, maybe a lake. And it says when the water gains energy from the sun, it changes from liquid to gas. So we have our liquid water here, and energy is hitting our liquid water, and that's turning it into water vapor, which goes into the atmosphere. And if we look at this little circle right here, there's a blow up of it, and it's showing us microscopically what our water molecules are doing. So we have water molecules colliding with each other in their liquid form, and as it gains energy, they become airborne. They come into the atmosphere, and it is a gas state then. So it says gas. Now we're moving on to transpiration. About 90% of water vapor in the atmosphere comes from evaporation from oceans, lakes, rivers, and other bodies of water. Where does the other 10% come from? The other 10% comes from transpiration in plants. Transpiration is the transport of water from plant roots to leaves, where it evaporates into the atmosphere. Like evaporation from bodies of water, transpiration is driven by energy from the sun. As shown in figure 1b, we'll look at that in a moment, plants have small pore openings called stomata on the underside of their leaves. Liquid water is released from the plant through the stomata. When exposed to the air, liquid water can evaporate. When liquid water evaporates, it draws energy from both the plant and the atmosphere as it changes state. This is important for plants because it helps them to regulate their temperature. The stomata open and close to control transpiration rates. When they open, transpiration increases. When they close, transpiration decreases. Does this process remind you of anything? I was just thinking that myself. A similar thing happens when people perspire. That means sweat. As the sweat is released through pores in the skin, it evaporates, drawing energy from the skin and cooling the body. Now we'll go look at that figure 1b. So here's our figure 1b, and it's called How Water Transpires. And I'm going to read what it says right down here. Transpiration is the process by which water is transported from plant roots to leaves, where it evaporates from small pores called stomata. And we can see a picture of stomata right here. This is microscopic because they're really tiny, on the underside of the leaves. Transpiration helps regulate the temperature of plants by causing energy to move from the plant to the atmosphere. So it's kind of like plants sweating. Thank goodness they don't stink like people do when they get really sweaty and stinky from exercising, or else it would be a very stinky world, wouldn't it? So we see the same picture that we saw above in that figure 1a, showing how the water molecules in a liquid state gain energy and become a gas state. And so that is happening on the underside of plant leaves. So I'm going to scroll down just a little so we can see the last little bit of reading starting right here with transpiration. And it says, transpiration also helps to draw new water into the planet, into the plant. As water evaporates from the plant's leaves, it is replaced by a new supply of water drawn through the roots and transported through the stem to the leaves. Evaporation and transpiration cause water to change from a liquid to a gas as it moves into the atmosphere. But what happens to the water vapor? Does it remain in the atmosphere? The next section will explain what happens to water vapor when it begins to cool.